All right, welcome kiddies to our last lesson for chapter 6. Today we're going to do a quick simple lesson on fitting lines to real life data. So this is going to be more on the real life, real world applicable side of linear functions. So first thing, when you graph data, now what do I mean by data is like when you were to do, say in science class you were to do a lab and you were to collect data on two variables. Take, for example, let's say you did a lab on weight and age. What you are going to find is that when you collect real-life data is that things don't necessarily work out perfectly. So when you graph points, when you graph a collection of age and weight, for example, you don't get a perfect relationship. You don't get a perfect line shown. So the first thing we're going to talk about is what's called a scatter plot. A scatter plot is simply a graph of points. So when you've been graphing points from a table or a set of points I may have given you, you've basically been drawing a scatter plot. But a scatter plot is more geared towards real life problems when you actually graph real life data. And when you graph a scatter plot, what you are looking for is you're trying to find a relationship between the variables. Okay, so what you're going to try and do is figure out how are they related. Okay, so for example, if we were to look at this graph here of age and weight, comparing these two things, what do we find? Well, we see that starting our graph from 0, 0, our origin, and we see that the age is going from 0, 5, 10, all the way up to 15. We can assume those may be our years, could be months, we don't know. But as we see that our age is increasing, as this is getting bigger and bigger and bigger, moving from the left to the right, what do we see is happening to our weight? Now, we don't see it happening perfectly, but we do see that the weight starts from about right here, whatever this value is, and it increases as the time goes on. So what we can see here from the scatter plot, this graph of real-life data points, is that there is a relationship between age and weight. That age gets bigger, your weight gets bigger. And if you think of real life, well, that kind of makes sense. And this is the whole purpose of today's lesson, is we're going to be looking at different scatter plots and trying to determine if there is a relationship shown in those graphs. All right, so here's another example. The table on this slide shows the number of species added to the endangered list and the threatened species list in the United States during the years of 1996 to 2002. So if we were to look at this data, what we can do is go ahead and graph it. Okay, so I have this graph for you, but this is what I'm talking about real life data. That notice here that it gives you the number of species during these certain number of years. So each of these in this table, each of these sets represents data points. So for example, this first one represents the point of 1996, the year of 1996, and 91. The second one represents the year of 1997, paired up with 79. Okay, so each of these is giving me a data point in which I could graph. Okay, so if I were to ask you to graph this, which I already have done for you in your notes, we can use this table first to make ordered pairs, which I have just shown you. Once we find these ordered pairs, then we can graph it. Notice here that I have the year as my x and the number of species as my y variable. And then when I plot the ordered pairs, what I can do is see the overall relationship. So if you look here, what is the overall relationship between the number of years and the species on the endangered or threatened list? And you can see that in 1996 it starts all the way at 90, and as the years progress forward, what happens to the number of endangered species? You can see that it's starting to go down. It's starting to decrease. We can see by this trend, the next year it goes down, it goes all the way down to here, goes back up a little bit, and then it starts to decrease a little bit. Now, you can see at this point, we saw that it started to increase, but the overall trend that we see is that they are decreasing over time. So again, not perfect data. You're not getting data that goes in a perfectly straight line like this, but you are seeing a general trend. You are seeing a relationship of the variables from those data points. And that's the whole purpose of this lesson. Okay, so basically what we're doing here is we're trying to determine a relationship. So there's going to be three types of things we're going to look at now. When we talk about a relationship, the word we're going to fit here is what's called a correlation. A correlation simply describes the type of relationship we see between the two variables. So I showed you two already. I showed you the one between age and weight. I showed you it between species and years. So the first one we saw, age and weight, we saw that as one variable gets bigger, we also saw that the other variable gets bigger. This is known as a positive correlation, a positive relationship. Why positive? We are saying it's positive because both things are increasing. Whereas with the endangered species in a number of years, we saw that it was that as one got bigger, the other one got smaller. Okay? So this one we see a negative correlation. Negative simply telling you that one of them is decreasing. Now, notice here, are both variables decreasing? And the answer here is no. Remember that when we read a graph, we always read a graph left to right. So our x variable is always going to get bigger. We're going to see that as x gets bigger, what is happening to y? Okay, so we're always going to look at what is happening to the y. Remember that x and y are related to input and outputs. Okay, so y depends on what x is. It is dependent on x, meaning it relies on it. So as x increases, we can see that as that changes, we're going to basically try to figure out that as x changes, as my input is changing, what is happening to y. So we're really looking at what's happening to the y variable. And then the last one we could possibly see is we could possibly see that you just get a hot mess like this, that nothing's really going on. You can't tell if it's increasing, you can't tell if it's decreasing, so you're just not sure. If you're not sure, this is called no correlation. That means there is no visible relationship between the data sets. All right, so let's take a look at two examples here. First one I have TV watching and test scores. So you can assume here we have watching TV, which is shown in hours, and test scores, and we have a bunch of points plotted here. What I want you to be able to do from this graph is to simply describe the correlation or the relationship between the data points. So what do we see? Well, we see that as we have TV hours down over here in the low realm. Think of on a graph, your hours are going to get bigger as you watch more hours of TV. What's happening to your test scores? Well, you should see that the test scores are getting lower. So what sort of relationship would this be? This would be a negative relationship or a negative correlation. We can just simply write down negative. Okay, next one we have snowboarding competition. We have the number of participants as the Y and the number of years as the X. So what do we see happening? We have the years of 2001 to 2007, so the years are increasing. So again, remember the X is increasing. What happens to the Y? Well, we see the Y is starting somewhere around maybe 27, and it ends around somewhere about 55, so we see that the number of participants increased. So what sort of relationship will we have there? This would be a positive relationship. So not overly difficult stuff here that we're dealing with, but again, it's just going to be more real-life stuff applied to linear functions. All right, next example here, we're going to take a look at identifying correlations, but now through a verbal phrase. When we do this again, we're going to be looking at two things, and we want to determine how they're related. Now, what you're going to have to figure out when doing this is you're going to have to figure out which one is your input and which one's your output. Which one depends on the other. So the first one, we have the number of empty seats in the classroom and the number of students seated in the class. So which one's going to depend on the other? Think about which one, if I think of my arrow here, which one would be my input? Which one would affect the other? Well, if you think about it, the number of empty seats is not going to affect the number of students, but the number of students is going to affect the number of empty seats. So the way I'm going to do this is I'm going to think of the number of students, and I want to think about how that's going to affect the number of seats. Okay, so let's think about this. Here's what I want you to think about. Remember, the input we're always going to view is increasing. So if I increase the number of students in my class, what do you think is going to happen to the number of empty seats? I should say here the number of empty, sorry, I'll be more specific, empty seats. Well, if you think about it, it's pretty obvious. The number of empty seats should decrease. That means I'm going to have more students. More students are going to fill those seats. The empty seats are going to decrease. So what sort of relationship do you have there? It is negative. All right, next example, we have the number of pets a person owns and the number of books that a person read last year. Okay, so the number of pets a person owns, let's see, I own one doggie, she's adorable, and the number of books that a person read last year, let's see, I read one book. Well, that makes sense, right? The number of pets and the number of books. So let me ask you this, what depends on what? Does the number of books depend on the number of pets I have? Or does the number of pets I have depend on the number of books I read? Interesting. You should notice something here, kiddies. If you try and figure out which way it goes, which one affects the other, it doesn't make any sense, right? It's kind of nonsense. So what does that mean? You have positive, negative, or no correlation. Are these things going to be related? And hopefully you're thinking in your head, this doesn't make any sense. It's exactly right. Because sometimes two variables have no relationship at all. Okay? Empty seats and students make sense, but number of pets and books does not make sense. So in this case, there would be no correlation between those variables. All right, now putting this all together, how does this actually fit to lines and linear functions? All right, I kind of mentioned this term already, but the one thing we're going to talk about now is what's called a trend line. Once you identify the correlation as either positive or negative, or possibly no correlation, what you're then able to do is to identify what's called a trend line. A trend line is going to show the trend. The trend is another word we use to describe the relationship. So it's a line that depicts the relationship shown in the data. So the data is not going to give us a perfectly straight line, but we are going to see a general relationship that we can then fit a line to. So let's give you this example. So we have a scatter plot here that shows the money raised versus the number of rolls sold. This is for a fundraiser. All right. So it's showing money collected and the total number of rolls of wrapping paper sold. We can say that this is during the holiday season, selling wrapping paper, rolls of wrapping paper, and the money raised. So think about what happens, and this might be an obvious relationship. Think of the last example. As you are raising money, if you sell more of the wrapping paper rolls, what's going to happen to the money collected? You should hopefully think that as the rolls increase, that the money raised will also increase. So we see that this is going to be a positive correlation. Once we identify that, the next thing we want to do is what's called a trend line. So notice the data points. We see that the data points are increasing. So think of these as general points on a graph. What we've always wanted you to do was to connect those dots or those points with a line that represents that linear function. But in this case, notice the data points aren't exactly perfect. They don't form a perfectly straight line. But I do not want you to just connect the points, okay? We're not just doing connect the dots here. But what I can do is I can draw an approximate line through the data points, okay? And what that's going to do is it's going to show, not a perfect, but it's going to show the general estimated relationship between those data points. So this blue line right here, this is known as, right here, this is my trend line. So it's a smooth line that doesn't connect, but it goes through the data points. Is this trend line going to go through every single point? No, you can see right there that I didn't hit that point. I kind of went between these two. I hit there. The trend line is not always going to hit every single point, but again, it's just showing the general relationship, what is about happening. Now, why is this important? Well, if I get this trend line, I can take this trend line and I can trace it beyond and beyond. And what does this allow me to do? Once I see this general relationship, what I can then do is make predictions. So I can start to predict things. So if I see this general relationship that it's increasing, now I can say, okay, based on the data, is $1,200 a reasonable prediction for selling 175 rolls? So basically saying, if I sell 175 rolls, is saying $1,200, is that a reasonable prediction? Okay, so let's take a look. How am I going to figure this out? Well, 750 rolls. If this is 150 and that's 200, 750 would be about right here. Did I say 750? I meant 175. I think I kept saying 750, but I meant 175. 175 is halfway between 150 and 200. So if I use this, if I trace 175 all the way up, I see that it hits the line, my approximate trend line, about right there. Well, how many rolls does that pertain to? Well, if I go all the way over here, I see it's right there, right between 1,000 and 1,200. So I see that technically that is $1,100. Not $1,200, but $1,100. Okay, so if I sell 175 rolls, I can predict using my trend line that I'm going to make $1,100. Now, how does $1,100 compare to $1,200? They're reasonably close. So I would say yes, this is a reasonable prediction. But the whole purpose here is once you have your trend line drawn, then you can start to make predictions as to what is actually going to happen beyond what your data is. Our data here stops at 150, but because of my trend line, I am now able to make predictions. And that's kind of a huge thing when it comes to real world stuff. And this is stuff that is used beyond the scope of this class, stuff that's used in science and stuff you might see in your future. Okay, so this hopefully wasn't overly difficult stuff. Again, we're fitting lines to data. Make sure you write down any questions that you have. Good luck on the practice problems, and we will see you guys in class. Peace out. Big Dog's out of here.